Welcome to qnawire.
What's up, StatCats? In this video, we are given an example and asked to perform a one-way ANOVA followed by a post hoc test if the results are significant. So let's go ahead to my Excel spreadsheet where I have the raw data copied over. So this is weekly unemployment benefits between different states. We are told our alpha level is 0.05, so let's go ahead and do the ANOVA test. So we're going to select all of our data. We do have labels and our alpha level is 0.05. Let's go ahead. Okay, so we have a significant result if our test statistic is larger than our critical value. So is 17.17 greater than 3.68? Yes, it is. So we do have a significant ANOVA result. So we can reject our null hypothesis. So there is evidence to support that at least one mean is not equal to another mean. And because we have a significant result, we can go ahead and do either a Scheffé or a Tukey test. And if we look at our sample sizes, they are the same. So we will be performing a Tukey test. So in order to calculate our numerator, we are going to take the difference in means between our pairs. So I'm going to pair Florida and Pennsylvania, Pennsylvania and Maine and Florida. So let's take our difference of these. And then we are going to take the square root of our mean square within group over our sample size, which is 6. Okay, so this is our denominator and this is our numerator. So to get our final value, we're just going to go ahead and do that final calculation. And we are getting some negative values, but an F value is never going to be negative, so we can just go ahead and take the absolute value of these numbers, so just going to consider them positive. And because we're doing a Tukey test, we find our critical value with the end table. So K is going to be the number of our means, so that's 3. And V is going to be our total population, so 6 times 3, which is 18. And we're going to subtract K from that, so it'll be 15. So let's go ahead to our end table, find our critical value. So 3 for K and 15 for V. That's 3.67. Okay, let's go ahead and go back to our whiteboard. So our critical value was 3.67. 1 and 2 was 8.17, 2.91, and 5.27. Okay, so we know we have a significant pair if that value is greater than our critical value. So is 8.17 larger than 3.67? Yes. Is 2.91? No. Is 5.27? Yes. Okay, so we have two significant pairs. So there is sufficient evidence. To conclude that there exists a mean difference between pairs 1 and 2 and 3 and 1. Alright guys, that's it for this video. I hope you learned a lot, and I'll see you next time.